Hello and welcome to a video on calculating the sum of interior angles in polygons. So first of all, what do we mean by polygons? Well, a polygon is just a shape with straight edges. So these are some examples of some polygons. So a circle is not considered a polygon because a circle obviously has a curved edge. So we're only going to be looking at polygons and we're going to be focusing on the interior angles. So that is the angles inside the shape, so these angles here. So for example, this angle, that is an exterior angle, so we're not going to be looking at that today. So the sum of the interior angles for each of these polygons, and hopefully by the end of the lesson we will be able to calculate the sum of interior angles of a polygon with any number of sides. So for example, a 100-sided polygon, you will be able to know what the sum of its interior angles is. Now, this all starts with one piece of knowledge that you should already know, and that is that the sum of interior angles in a triangle is 180 degrees. Now, I'm not going to prove this statement in this video. I will do a separate video on this, but for today, if you just take this as a given, that the sum of interior angles of any triangle always adds up to 180 degrees. So it doesn't matter what type of triangle, these three angles will always add up to 180 degrees. Now we can use this information to calculate the sum of interior angles of any polygon. So let's first of all start with this quadrilateral down here. So what I'm going to do is I'm just going to pick a point on my quadrilateral and I'm going to draw a line that goes from this point to the other side, so over here. Just make that black. Now, hopefully you can see that we form two triangles. So if I just first of all focus on this triangle, I know that these three angles that I'm drawing in magenta, well, they sum to 180 degrees. And if I focus on this triangle, well, these angles in blue that I'm drawing, they also sum to 180 degrees. So now if we add the blue and magenta angles together, because those angles comprise the quadrilateral, well, we can see that in total it's going to add up to 360 degrees because we just sum these two numbers together. And now if we look at this pentagon over here, we can do exactly the same thing. So let's pick a point on our pentagon. Let's pick this point here. It doesn't matter which point you pick. But from here, if I just draw a line that goes over here, you can see that we've created one triangle. And if I just repeat that process, let's draw the line that goes down here, I've now formed two more triangles. So we know that each triangle, the angles in each triangle, sum to 180 degrees. So to calculate the sum of the interior angles of this pentagon, well, it's just going to be 3 times 180 degrees. So 3 times 180, well, that gives us 540 degrees. And now finally, let's take a look at the hexagon, and we can do exactly the same thing. So if I pick a point on my hexagon and draw some lines. So first of all, I'm going to go up to this point over here. That's formed one triangle. Now if I do the same but go over here, I've formed another triangle. And finally, if I go down to this point down here, I've got two more triangles. So I've got 4 triangles in total. And we can see that each triangle, the angles must sum to 180 degrees. So now we can see that the sum of the interior angles of this hexagon must be 4 lots of 180, which is 720 degrees. Now, after going through these 3 examples, hopefully you can see that all we need to use is the fact that angles in a triangle sum to 180 degrees to calculate the sum of interior angles of any polygon. So as you can see, I've just drawn a table over here, and hopefully we'll be able to use this table to come up with a formula to calculate the sum of interior angles of any polygon. Because if we're thinking about, for example, a polygon with 50 sides, well, drawing all of these triangles out, we're going to be here all day. So if we come up with a formula, it's going to be a lot quicker. So if we start with the quadrilateral, which was the first one we went through, quadrilateral has 4 sides. How many triangles did we create from that triangle? Well, we created 2 triangles. So to calculate the sum of interior angles, what did we do? Well, we did 2 times 180 because each triangle, the interior angles sum to 180. So 2 lots of 180, well, that's 360 degrees. Now onto the pentagon. Well, pentagon has 5 sides and we made 3 triangles this time. So our workings out to get the sum of the interior angles was 3 times 180 degrees. And 3 times 180 is 540 degrees. And finally, the hexagon, well, the hexagon has 6 sides, and there are 4 triangles that we created. So our workings, 4 times 180, and that gave us the 720 degrees. Now, if we're moving on to the next shape up, so if we just follow the pattern, we'll be looking at a 7-sided shape, which is a heptagon. Now, I'm not going to draw it out, but how many triangles do you think we can make from a heptagon? Well, if we follow the pattern, we're just going up by 1 each time. So there's going to be 5 triangles. So to calculate the sum of the interior angles, well, we're going to do 5 times 180 degrees. And I think I can do that without a calculator. Well, that gives us 900 degrees. Now, hopefully you're spotting a pattern here, is that every time we increase a side length, we increase a triangle. So, for example, if we had an octagon with 8 sides, well, that's going to generate 6 triangles. So to calculate the sum of the interior angles, it's going to be 6 times 180 degrees, and that is going to give us 1080 degrees. Now, what about if we had a 50-sided shape? So just pause the video and see if you can come up with a rule to enable us to calculate the number of triangles first of all, and then from that we can calculate the sum of the interior angles. So I'm assuming you've paused the video and given that a go. Now, the relationship between the sides and the number of triangles is always that the number of triangles is 2 less than the number of sides. This number in this column is always 2 less than this column. So if we have a 50-sided shape, I'm not sure what the name of this is, please forgive me, but I know that there are 48 triangles that can be created because it's always 2 less. So to work out the sum of the interior angles, well, it's going to be 48 times 180, because we know that each triangle, the angles sum to 180. If we've got 48 of them, well, it's going to be 48 times 180. And for this, yes, I will, I think, need my calculator. So 180 times 48, and we get 8,640 degrees. Now, so far, we've just looked at specific polygons with these number of side lengths. What about if we wanted to generalize the formula to calculate the sum of interior angles of any polygon? Now, this is where we start to use a bit of algebra, and we can use a letter. So let's just use the letter N to represent a polygon with some number of sides. Okay, it could be any number. So it could be 10, it could be 100, it could be 1,000, but we're just going to use the letter N just to represent any number of sides. Now, first of all, how many triangles would this polygon create? Well, we have already said that it's 2 less than the number of sides. So if the number of sides is n, well, the number of triangles is going to be n minus 2. And now we can work out an expression for the sum of the interior angles, because however many triangles there are, we just need to multiply that by 180. So our formula is going to be n minus 2, and I'm going to put that in brackets, and then we multiply it by 180. And this is the formula we can use to calculate the sum of interior angles of any polygon. So all we do is we put the number of sides into this formula, and that will give us the sum of interior angles. So just to finish up, let's use this formula to calculate the sum of interior angles of these different polygons. So first of all, we've got a 10-sided polygon. So what we're going to do is we're just going to put this number for the number of sides into our formula where n is, because n represents the number of sides. So it's going to be 10 minus 2 times 180, or 8 times 180. So I'm just going to use my calculator for this, and that gives me 1,440 degrees. Okay, let's do the next one. So a 100-sided shape. So this time it's going to be 100 minus 2 times 180. So that's 98 times 180. 98 times 180. That gives us 17,640 degrees. Very hard to visualize. Something like this would look like a circle. You wouldn't really see the sides, and even more so on this one over here. So the last one, well, this is going to be 4,171 times 180, because we just need to take away 2 from the number of sides. So let's type that into the calculator, and that gives us 750,000 780 degrees. Now, these are a bit excessive, but I'm just trying to reinforce the point that you can use this formula to calculate the sum of the interior angles of any polygon. Now, just one last thing before I finish. I don't like people memorizing formulas, so I always like to think about where the formula comes from. So always try to think back to angles in a triangle summing to 180 degrees, and it's all to do with how many triangles can you make from that polygon. And however many triangles you can make, you can obviously just multiply that by 180 degrees, and that will tell you the sum of the interior angles. So, thank you very much for watching, and hopefully I'll see you in the next video. Take care.